As I was saying, so I forgot to click the record button. My period 5 class has been so gracious to record the notes with me in utter silence.
You're welcome.
Okay.
Call 911.
This is why I had a problem doing this. Okay, right there. All right, so as I was saying, the first thing you're going to deal with in these triangle situations is you're going to ask yourself, is it a right triangle? And if you can say yes, then you will be using SOHCAHTOA and nothing else. I mean, we're going to get to the test questions, and I promise you there'll be some right triangles on there. You need to look at it and say, is it a right triangle? Okay, I'll use SOHCAHTOA. Not try to hit it over the head with a bigger hammer, right? Okay, you want to use the appropriate tool. SOHCAHTOA works great for right triangles. But if it's not a right triangle, then you need another plan. And so the law of sines would be the second step in the process. Now, if the law of sines fails, then I would be going with my backup plan, which is the law of cosines. And that happens to be section 5.2. So I really don't like the order they put this in the book. So that's why I do section 5.1, then section 5.4, then section 5.2. So because that is the exact order I would follow when I'm looking at a test question to know whether I'm going to handle it with SOHCAHTOA or law of sines or law of cosines. The law of sines is simply a proportion. Right? Now, these angle measurements and sides have a relationship to each other. So that's an angle. Capital letters are used for angle measurements. The lowercase letters are sides. And those happen to be opposite of each other. So angle A and side A are opposite of each other, just like angle B and side B are opposite of each other. Now, in order to use the law of sines, the key is having a known angle and a known opposite side. That's the absolute must. It is a requirement. Otherwise, you can't use the law of sines. So make sure you understand that. Have it written in your notes, even if you need to go back and watch it again, because this is the absolute must for using the law of sines. So, given a particular situation, you've got a triangle. Please note that I've labeled the angles capital H and the side opposite lowercase h. Capital F, lowercase f, capital B, and this would be what letter?
D.
Oh my goodness.
H for Harry, my name.
No, I did not do that. Why did I do that? Okay, just because the book has it. Why?
Wait, why is it B?
Because it's opposite angle B.
Oh.
E equals 400. Are we talking in terms of feet here? Or just units?
They're just numbers. Don't worry about the units.
All right.
You can make up your own units if you'd like. So, is it a right triangle?
No, homie. Well,
No,
is it-
homie.
Is it? I can't. No.
No.
It's not a right triangle. So, glad we got that established. Is there a known angle and a known opposite side?
Yes.
Okay, now, a lot of you, I'm amazed, nice job, but a lot of you say no immediately. They're like, because you don't see one in there. But we remember from geometry that when you know these two sides, we can figure out the last one, which is 30 degrees. And now it is clear that we have a known angle and a known opposite side. And for the people at home, I just wrote this down. I know you already know that because we already talked about it. Okay, but that's just for their note-taking.
Viewing pleasure.
Yes, viewing pleasure. Right? Now, this is pretty easy to solve here. Let's suppose I wanted to find side H. No, that's not little Harry.
Harry. Harry.
No. Don't answer that question. Okay, now, we've got the sine of the 30-degree angle opposite what side? 400. That's the known angle and the known opposite side. You've got to have that, otherwise you cannot complete the process. Since we are looking for side H, we will have the sine of 110 over H. It's a proportion. Use it, thy machine. 2 cross, multiply. And what do we get for H? Hit your own enter button.
Got this.
You got that?
I got 751.
Never mind.
How convenient.
At the same time.
Yeah. No suspicions there, New England Patriots. So, yeah, we know each unit. 751.75. There you go. There's the. I should put the little approximate symbol in there.
Yeah.
Yeah, because it's not exactly.
Our pod's not like that.
Our pod would not like that. That's the easy situation for the law of sines. There are two situations where we could come up with, let's just say, a little bit more interesting results. The first one actually comes from example 3 in the book. You're given this information in triangle XYZ, X is 10. So where should I put that information?
Probably by the pencil line.
Probably here,
I have no idea.
I'm just
but it's a lowercase x. That's a side length.
Oh, that's hard to tell. That is.
How can I tell? Because the other one looks bigger.
I just.
I can't.
Sorry, I understand. So side length of 10 must be opposite angle x. The measure of angle x, 42.5. And side z is 3. And here's how we all get away with murder in geometry.
Not drawing scale.
Yep.
I think that's not how we work here.
Well, seeing as the side length of 10 is shorter than the 3, yeah. You could make all your triangles equilateral if you want to, as long as you label them correctly and put the information in the correct spots. It doesn't matter to me. Do you understand?
Well,
Okay.
why didn't it be like right triangles?
Possibly. But at this point, I don't know that. So, do we have a known angle and a known opposite side?
Yes.
Okay, so I see that right there. So I know that I can use the law of sines. It's not a right triangle, so I can't use basic SOHCAHTOA. So we have sine 42.5 over its opposite side of 10 equals the sine of angle Z over its opposite side of 3. So, when you do your cross multiplication, what is the sine of angle Z? So 3 times sine 42.5 divided by 10. Did you get this? Is that angle Z?
No.
No, that's not angle Z, folks. That's the sine of the angle Z. So you still have to do one more thing, which is invert the sign, right? So this is approximately equal to the point 203. So Z is going to be the inverse sine of 0.203, or I should approximate it. Okay, but I'm just going to use my inverse sine of the answer feature on my calculator. So angle Z is 11.69,
Approximately.
approximately,
I said approximately.
just to get his name out there.
My name's Harry.
Okay, all right. Oh my goodness. As the trigonometry turns. That's a good unit circle joke. All right, so the case that you dealt with was this. The case that you were dealing with looks like this. Capital S, little f, A. No, you can't write it the other way.
Oh, so that's happening.
Okay, now, keep in mind that I've drawn the larger letter side first. It is opposite the angle. When you look at the angle measurement in the triangle, it is opposite the larger side. That would be the larger side. This has only one solution, and it's 11.69 degrees. That's it. I know you're asking yourselves, how could it possibly be anything else? Well, along came example 2. Example 2 is different. It has a smaller side opposite the angle measurement. This is the situation which will present 2 possible solutions, of which we will go through and possibly run out of time, and you will have to continue to watch the video once we get done. But I'm given this information about triangle ABC. I started to draw one triangle, and then I realized this isn't going to be a very good triangle to illustrate the point, so I redrew it.
Oh wow, I see 2 triangles. Right?
You did? Okay, cool. You can scribble out the first one in your notes. All right, now, in this particular triangle, we have a 32-degree angle down here. It says angle A is 32 degrees. Lowercase a is 5. That would be opposite that side. Lowercase c is 8, opposite angle C. Do you see that the smaller side is opposite the angle? This is the 2-situation case. Now, I realize that you're going to set it up, sine 32 over 5 equals the sine of angle C over 8. Here's the problem that you don't necessarily see right away. Do you know anything about angle B? Nope, I don't know anything about angle B either. Do you know anything about side AC, or where we would call it lowercase b? Do you know anything about that side? Absolutely not. You don't know anything about either one of those. So here's the problem. I don't know whether this side length of 5 is over here, or whether the side length of 5 is actually over here. In which case, watch the triangle, it could be an obtuse angle. I am not sure. There are 2 possible cases. That does not happen in the last example we did, but in this example where the short side is opposite the angle, you end up with 2 possible solutions, which you'll have to watch in the rest of the video, along with the 5-2 law of cosines video. But the 5-2 is already on right now.
I love math.
Okay, well, you finally got to escape.